And welcome back to another True North webinar. Today we're going to be looking at how to model this crank. So I'm going to walk you through step by step by step. I've modeled this once just so I could understand the different inaccuracies of the model from the drawing. So now we're going to walk through from start how to actually create this. Let's go and have a look at the finished model. So in my finished model here, we've got a series of planes that represent all of the different feature limits. In here, we have two centers. And then inside of here, we've also got a construction plane for the Y plane, and then a Boolean constructed model that defines all of the different bits and pieces that we're going to have to draw in order to design this crank. And they're all put together. And then we may, at the end, look at how we could better organize this tree to help organize the features for update. Okay, without further ado, let's get started. So let's create a new part. And first thing, I always delete this guy. First thing we're going to do is insert a body. And into that body, I'm going to insert a geometrical set. So every feature should be contained within its own body. And I like to keep all my construction elements for that feature with the feature itself. So I'm going to put all of those construction elements, planes, sketches, points, lines, whatever, inside that construction geometrical set. And then that way, if I have to go and modify that feature, I know exactly where my wireframe elements are. Okay, so I create one, and I use that as almost like a template. So I copy and paste. Let's also insert two geometrical sets or three geometrical sets. So the first one is going to be for all my planes. My second one is going to be for my center lines. My third one is just going to be for any global information that I need to share across all of the different features. Okay, so the first thing that we want to do is define all of our planes. So I'm going to actually start off with a plane by equation. I don't like using the base planes. If I have to turn this into a template, I want to keep everything separated away from those planes. So we're going to create an X-plane at 0. So there's our first plane. Let's set the color of all these planes to be purple. Let's make all my center lines green. Let's make those dot dashed, slightly thicker. And all my globals are going to be light blue. Okay. Why did you not go purple? Ah, purple. Okay. So let's rename this one. So this is my X-plane. I'm going to also create a Y-plane. And maybe we should move those to the globals geometrical set. Kind of makes more sense. And I did say I wanted those to be blue. Okay, so there's our first two planes. What we're going to do now is create all of the rest of the planes. So I'm just going to use these values. Now we have to be a little bit careful in here because there are these 2mm offsets. So really the distance for this gap is not 33, it's 37. This gap is 25, not 23. So I'm just going to move this off to the side and start creating all of those planes. To do that, I'm going to just use plane offset from plane. We're going to start off with that X plane. Let's move this so we go in the right direction. So the first one is 22, 30 for the next one. And then for the next one, it's going to be 25. But then I'm going to come back -2 for that little shim. So then from here, I am going to need, this is really tricky. So you've got to be very careful as you do this. So that was 25. The next one is going to be 22. That gets me to there, and then 30, 37 gets me across. From this one, I'm going to want to come forwards. Oh, forwards 2, not -2, so just 2. And then from this one, I want to come back by -2 for, again, for the little tiny shims. So I'm just doing my math. So we went, instead of 23, we went 25, and then we came back 2. From here, we went 22. Because I was actually here. So that should be 20. That should be 20 dead. Again, got to do some mental gymnastics here as we go through all of this. So this is -2. That's my 20, 25. 22. 30. Then I want to go 25, that's correct, back 2. And then from my 25, I want to go 20. What? 22. And then 2. And then from here to here, I want to go 37, back 2. Okay, getting there slowly. And then from here to here is actually going to be 20. Yeah. 20. From here, I want to go 2. And then from here, I want to go 23, 24, 27, -2, and then from there I want to go 22, and then we go +2, and then from here it's going to be 37. Oh, what did I do? $37. Did I create 2 of the same ones? I did. Okay. And then from there, we want to go -2. And we're nearly there. So from this guy, again, we want to go 20. Then 2, and then from here we want to go 25, and then 15, 15, 10. Okay, and then 15, 15, 10. All right, so there's all of our planes that we need. So the next thing is the centers. So we know if we create a point at 0, 0, 0, let's actually put that into our globals. And we'll set this as origin, properties, graphics. Let's make that a dot, and we'll make that nice orange. There we go. What we can do now is draw our center line. So we're going to point direction. And for our end, we're going to pick this end plane and say, okay, that's that guy. And if we go back to the drawing again, what we need to do is establish this center line here. So it's a little bit tricky. looking at this drawing, we know that the distance from here to here is 80. So, and it looks like on this guy, so we're 120 to the top. And if this is 80, so then we've got to come down 40. So 120 minus 80 is what? 120 minus 80 is 40. So it looks like it's 40 between centers, I think. Let's go look at my other model and have a quick measure. I think it's going to be 40 between the centers. Yes, I got it. I made a mistake on the other one. All right. So now we know that. Let's go create another line. Point direction. Let's use the running commands. So we're going to create a point. Reference point is going to be my origin. We're going to go up by 40. Say OK. And then we will need a direction. So we use this plane and we'll go up to here. All right. So now we have our two center lines. Let's call this main center. And we'll call this row center. All right. So now we're able to carry on modeling. So let's look at this first end. So we've got a series of steps. I'm going to ignore these little tiny pieces for now. I'm going to come back and do those at the end. So I'm also going to ignore this thread. So we have 3 steps, 1, 2, 3, at radius 35, 45, and then we don't seem to have a dimension this end, but we do have a dimension this end, so I'm going to assume that it's 66. So let's go ahead and draw that out first. So as I said earlier, I am going to copy and paste one of these bodies. I already have one here, so let's define a work object on the construction, create our sketch. So we want a position sketch. We're going to sketch on this plane. My projection point, I'm going to use my origin and parallel to line. So we're going to say parallel to this line. Let's have a look at my V and H. Are they back to front? It looks like they are back to front. So let's say H. Let's reverse the V. Okay. So that's got the right orientation that I would like. And we can start to do drawing. So the way I like to do this is just to draw things out very kind of rough and not really pay too much attention to size. In this case, we're going to make sure we finish on the end, and we're going to start to throw our constraints in. Our first one is coincident, which is great. So we know that each element is going to be coincident to each one of these planes. And we'll use this one. And then we've got our diameters. So this one is a 35 down to this line. So 35 divided by 2. Next one is a 45 divided by 2. And the last one was 66, so we know that's a 33. Okay. So there's that. Let's just drag this over here a little bit. So we've got a 1 by 45, a 1 by 45, a radius 1, and a radius 3. So let's add those in. Let's do the chamfers first. So pick the 2 elements, type 1 on the keyboard. Let's do the same on this one. Then we have a 1 millimeter. And a 3 millimeter. And that should be our first profile complete. So let's exit the sketch, define a work object on the body. And if we've got everything right, we can now use the shaft and we can use our center line as the rotation center. It's okay, and we've got our first solid. Okay. Let's copy this body again. And we'll paste that in. And let's focus on the hole. So hole is an M20. The threads are 40 deep. The hole to the start of the bottom angle is 50. So an M20 should be about 17.5 millimeter drilled hole and then tapped out to M20. So let's do that first. So we're going to go to our hole function, pick the point, pick the plane. Let's make sure that's going in the right direction. So the main diameter is going to be 17.5. The main depth is going to be 50. We want a V bottom. So that is going to there. We're going to turn the thread option on. And we know that it's a thread diameter of 20 and the thread depth is 40. Let's just assume it's a 1.25 thread pitch and say OK. And now we've got our threaded hole. Now if we hide this, there's our threaded hole ready to go. I like to keep all my features separate. So let's insert a body and put everything together. So we know that we have to add this first block. And then we have to remove this one. So we've got one add, one remove, and the result for this feature branch looks like that. Looks great. Okay. If it was me, I'd probably put a little chamfer on there. So let's put a little chamfer on this guy. Let's just do a 1x45 just to help the fastener lead in. So there's our first end. Let's go and have a look at our second end. So our second end is something very similar. We do have 6 holes at 8mm diameter. There are 6 of them, so you need to remember those. So we're going to do a very similar process. So we're going to draw this out first, rotate it, and then we'll come back and put our holes in. Okay, so let's go ahead and do that. So again, we're going to copy that body, paste it in. This is going to start with our main section. So we're defining work object on the construction. Start with a position sketch on this plane, projection point of the origin, parallel to line. My H is good. I'm going to reverse my V. I like to keep everything the same. The other option that we can do, a lot of people don't know this, but if you can actually sketch on a sketch. So if we go back to our first sketch and pick this and say OK, now it's going to lock the 2 sketch orientations together. So that's much, much quicker than redefining the position sketch. OK. So again, we're going to ignore that little step that's in here. So we know that we're going to start from here. So we're going to come up, it steps up, comes across, then we've got that big flange. I'm not going to snap it to anything, just in case there are some differences, and then we come down and I'm good. So let's start off by making everything coincident, and so on. Okay. So the first diameter here is a 55. So 55 divided by 2. Our diameter here is a 102 divided by 2, so 56, or 51, sorry. Next diameter is going to be a 70, so that's a 35. And our last one is a 66, so a 33. Looks great. Okay. So what we need to do if we look back at our sketch, so we do have a 3x45 here. We don't have any other radiuses, so let's just put the 3x45 chamfer on. And there's our profile. So let's exit the sketch, define a work object on the body, use our revolute tool, use the center line, say OK. So there's that. So let's go ahead and do the holes. So the holes are a little bit different. So what I'm going to do again, so we're going to copy that body, paste that in. I'm going to recreate where I want that hole. So we're going to sketch on this plane, curve intersection to define the origin. And if we look on this sketch, there's a pitch circle diameter of 85 that the holes reside on, and the bottom hole is at the very bottom. Okay, so a PCD of 85. Let's create a circle. Let's make that construction. Let's make that 85. And we'll put a point at the very bottom. And I'm going to convert that point to an output feature. So when I exit the sketch, I have that point. It doesn't have to be on the correct plane. So let's define a work object. Let's go to our hole function. We're going to pick that point, then the plane, and now we know that it's not threaded. We're going to say blind. We could say up to plane. So let's just use this plane. So it forces the hole to go all the way through. It's an 8 diameter. And you have to be a little bit careful with the sketches for holes, and I'll show you why. So let's go change the sketch support. So we're on a sliding sketch. I prefer to say positioned. I'm going to make it curve intersection, so I'm going to force it to utilize all of the same geometry. And the other thing that we need to check while we're in there actually is to make sure, and it looks like it's good, we've got a coincidence constraint between, if we double click on this, between the mark and the point, and the mark should be our point. Last thing to check while we're here, quick analysis, sketch analysis, used edges, we're picking on that output, which is great. Okay, perfect. So now we've got our first hole. Let's pattern that out. Current solid, use the center line, crown, and we know that we want 6. So now we have all of our drill holes. So again, let's insert a body and bring everything together. So the first thing we want to do is add the end, and then we're going to remove the holes. So now we have that piece created. Okay, looking really good. So let's look at the drawing again and see what we're going to focus on. So we've got our 2 ends. It looks like this is pretty much symmetrical. So let's do this centerpiece, and then we'll focus on making this symmetrical about this center, which will flip over here. Then we can develop this centerpiece, and then we'll symmetric or mirror the whole piece about the overall center, which will get us this. And then we should be pretty much close to being done. So in order to do that, so this is diameter 70 here, so it is a 66 again. So let's do that real quick. So again, we'll copy and paste our body, define a work object on our construction. We know it's in this center region right here. So we'll do a sketch on this plane, making sure we're curve intersection. We'll draw our circle, 70. Oh, sorry, I said 66. Exit the sketch. No pad. That up. Now we're getting this error message because I forgot to define a work object on my body, so I'm going to do that real quick. We'll pad that up to plane. And I always define both. And there's our centerpiece. So the next thing that we're going to focus on is this shape here. So if we look at the drawing, we've got a 120 by 80 on centers. Okay. So again, take that body, copy paste it. I'm going to define a work object on construction. Now we know that it's going to be on this plane. Curve intersection. And we could say normal to surface and use our XY plane to make sure it stays vertical. I'm going to use the elongated hole. Let's delete that measurement. So we know that it's a radius of 40 or a diameter of 80. Let's make sure that these are parallel. And we can now use our center line. So we can say coincident What I need on this, I need to know where this outer edge is, and I'll explain why in a minute. I would also like to know where the bottom edge is. So what I'm going to do in this sketch is really box it in. So we're going to create a tangent construction line that's horizontal. I'm going to do that at both ends. And then I'm going to add 2 construction lines down here. And I'll explain why in a second. Okay. I want this to be my profile. I need these to be planes. So what we're going to do is go to sketch. We're going to say 3D plane. I'm going to pick on these elements, which removes them from the sketch. So we still have our inner profile, which is great. So now I have all of those planes. What I'm going to do now is do the side profile. So in here, the dimensions are shown. So it's 25 from the top, which would be also 25 from the bottom, 5 in from the inner surface here, and that defines all of the geometry for that shape. So we're going to do that as well. So we're going to create a second sketch. So we're going to sketch on this plane, projection point of our origin, parallel to the line. And I'm going to start off just by drawing a rectangle. And we can then use these planes to define coincidences. So we know that we have to go to this plane and this plane. Okay, so now I know where that is. If you remember on the drawing, it was 25 from the either end. So we'll make that construction element, put a dimension in of 25. Do the same at the other end. And then 5 in from the sides. So again, we're going to create a construction element with a dimension of 5. Okay, let's help with the visibility a little bit. We'll just turn this no background on for a second. So now we have that. We know where we can construct this line here from. Oh, and I think I missed it. I did. Let's do that again. So from here to here. And the same at the top. So it's going to go from here to there. We don't need it to be parallel because the geometry is going to define that. And what we can do now is just remove out all the pieces we don't want. So we don't want that bit, that piece, or that piece. Same at the top, we don't want this piece, and this piece. And if we go to the analysis, we can see that we've got one closed curve, and that's the profile I do want. So let's exit the sketch. So now I have 2 profiles. We can utilize, if I can find it, the intersection. And they've hidden it on me. Where did you go? There it is. Solid combine. So again, I've got to make sure that I'm defining a work object here. We're going to use solid combine to combine this profile and this profile and say okay. That's going to create that shape for us. On the drawing, we have in here somewhere a radius 10 and a radius 2. So let's do the radius 10s first. So we've got one here and one here. So that's a 10. And then we have a radius 2. So we can actually pick the face to make it a little bit more robust. Actually, what we can do better is pick this one face and we get both sides for a radius of 2. Okay, so now we have that. which is great. Let's define a work object on our construction because we do need a midplane. So our midplane in this case is going to be between here and here. So let's create a plane between. Define a work object, and we can do a mirror. So now we have that. That's great. Next thing we want to do is create this upper bearing surface. So again, it's in this case it's a diameter of 48. So let's copy and paste this body yet again. Define a work object on the construction. We're going to sketch. Let's use this plane that we've got. So we're going to sketch on this plane. Projection. We're going to say curve intersection and say OK. So it's just a cylinder. So I'm not too worried about rotation. And we know that it's a diameter of 48. So there's our sketch. We'll pad that out now. Up to our planes. So we know we're going to go to this plane and this plane. Excellent. There's no radius between it. It does have those little discs in there. So let's do those next. So again, let's insert a body. Find a work object. Let's sketch on this plane. Now those discs have a diameter. Let's bring the drawing over so we can have a quick look. So we've got 66, 70 right there. Okay. So when I did this, I did not define my sketch support properly. So let's make sure we do that. So we're going to sketch on position sketch on this plane, curve intersection, say OK. And we'll do our sketch. 70. And this time it's going to get padded up between those planes that are really close. So there's our profile, up to plane, this guy, up to plane, this guy. So OK. And while we're here, we can just do a mirror. And we've got all the pieces for this one side. So now what I'm going to do is going to insert a body. I'm going to group all those together. So let's find all those three pieces. So we've got 1, 2, 3. So let's right click. And then we'll add all those together in one go. Very nice. So now we can do, we've got that. Let's add a geometrical set in here. Properties, construction. So if you don't want it there, you want it at the top. The easiest thing to do is take these, select reorder, pick the construction, say OK, and it'll flip those over. We do want a plane between this guy and this guy. So now we can define a work object. We can do our mirror. And we have our other side. So things not quite right there. I think I got one of my dimensions wrong earlier on. So it looks like I miscalculated this 20, probably should have been 18. That looks much better. And it looks like I did the same right here as well. So this should have been 20. And that looks, maybe I did get that right. That was 20. All right. Now everything looks correct. Okay. So to finish up, we need to add in this disk in 1, 2, 3, 4 locations. So let's go ahead and do that. So again, we're going to copy the body. We're going to sketch on this plane, right? Let's do it on this plane, on here. Curve intersection on our curve. We know that's 70, so let's draw that circle out. We'll pad that up. And I always forget to do that. Okay, pad, now circle, up to plane, up to plane. There's our first one. We know there's actually mirrored all about here. So that looks perfect. And then since this is my last feature, I'm just going to define a work object on here. We're going to re-pad the same sketch up to plane. So we're going to go up to this plane in this case, up to plane, say OK, and then we're going to mirror it about that plane. And that completes all of the features for our crank. So last thing we have to do is really just glue it all together. So let's define a work object on the part body. We will go ahead, maybe we will pick these in a reasonable sequence. Disks, and we'll select add, say OK, and now we have a single solid. Let's do some cleanup. So we'll hide everything. Let's go find where these are. Hide that construction. Let's hide that construction. And we finished our component. Now, the reason why I like to build with bodies is I can step through and just work on a specific feature. So if you have your app options turned on, so to do that, you say display app options. Let's turn this guy off. Turn this one off. So this is only current body. This is only current operated solid. So when I define a work object on a specific body, it's going to show me just that feature and the content within that geometrical set. So now I can freely work on there. Let's do that. So this other one enables you to see the geometrical set as well. So now I can see that geometrical set. You'll notice when I turn this on, now I only see the solid. So, excuse me. So now I can come in, I can edit this one feature and do my update. The other nice thing about this, if we turn it back on again, there is a play button, if I can find it. Where are you? Tools, review. Scan or define a work object right here. So if we go back and select on this part body, we can then start to step through. Oh, start to step through. Am I hitting the right one? That's the update. And we should be able to start to step through the geometrical. Let's go to here. So this is next. We added that. So this body contains those features. So as we step through this tree, we can start to see how this was built. So then that was added to the part body. Next, we created this. If we expand this out, then we went to add that. That was then patterned. Then it was removed away. Then this was added to that. So let's expand these out. Then we create that pad. So you can start to play through and see how this model was built. And then when you get to the position or the place where you want to go make your change, you can then go make it by working directly in that feature body, that branch. So I like working this way. It keeps my tree well organized. The other thing it does for me is that if I want to replicate a feature, I just have to copy the whole branch, or create a power copy would be a better solution of that body or this body or the whole thing, and then I can reuse that in another part somewhere else. Hope you enjoyed today's webinar. My name is Mark Jeeves, and I look forward to having another one with you in the future. Have a great day.